for determining the geometry of borane, carborane metal clusters, transition metal clusters also, by using the valency electron. So what is borane? Borane is the hydride of boron. So sodium hydride means NaH. So boron hydride is BH. BH. Let's say BnHn. So boranes are of different types: Closo, Nido, Arachno, Hypo, etc. So closo borane is what? A triangulated polyhedral structure. It is a closed structure, that is closo. Closed polyhedral structure. So in closed polyhedral structure, all vertices are there and it is called closo borane. And the formula is, general formula is BnHn plus 2 or BnHn 2 minus. So this is the general formula for closo. By using BnHn plus 2, we can determine or we can come to conclusion that the given structure is a closo. If we get BnHn plus 2 formula. And coming to Nido, from polyhedral structure, one vertex is removed. One vertex is removed in Nido. So it is not a closed structure now. So it is called a Nido borane. So BnHn plus 4 is the formula for Nido. BnHn plus 4. And for Arachno, BnHn plus 6. BnHn plus 6. And here two vertices are removed. And for hypo, it is BnHn plus 8. And for conjuncto, BnHm and n not equal to n. So these are the types of boranes: Closo, Nido, Arachno, Hypo and conjuncto. Using these general formulas, we can determine the geometry of the given compound or complex. So we have seen the structures of boranes. Now moving on to Syntae ions and transition metals, the same criteria is used for Closo, Nido. The difference is, instead of BnHn plus 2, we use 4n plus 2, where n is the number of metal atoms, number of atoms. So 4n plus 2 for Closo, and 4n plus 4 Nido, and 4n plus 6 Arachno, and 4n plus 8 Hypo. Similarly, for transition metals, if transition metal complex is given and we have to find whether it is Closo, Nido, Arachno, etc., then we will count the electrons and come into a formula. If it is 14n plus 2, then it is Closo. If it is 14n plus 4, then Nido, and 6 Arachno and 8 Hypo. So for 2 Closo, 4 Nido, 6 Arachno, 8 Hypo. So these are the formulas for Syntae ions and transition metals. And for boranes, BnHn plus 2, BnHn plus 4, plus 6, plus 8, etc. And the stability order of borane is Closo greater than, Nido greater than, Arachno. So this is the stability order of boranes. Stability order of boranes. So Closo is more stable than Nido and than Arachno. And coming to acidity order, greater the size, greater acidity. So greater size, greater acidity. So acidity increases when borane structure, borane cluster is in greater size. So stability is order Closo, Nido, Arachno, and acidity increases when size increases. So let's solve some problems. So let's solve these problems. First one, B for H10. So n is equal to 4. N equal to 4. The formulas are BnHn plus 2 Closo, n plus 4 Nido, n plus 6 Arachno. So n is equal to 4. So plus something that we don't know. So 10 minus 4 is 6. So 4 plus 6 is 10. So N plus 6. N plus 6 is for arachno. So just subtract these two, then we will get that number which should be added with N. So here N is 4. 4 plus a number gives 10. So 4 plus 6 gives 10. That we know. So N plus 6 is arachno. So B4H10 is arachno in structure. Now coming to B12H12 2 minus. So we already said BNHN 2 minus is Closo. How? Here 2 minus. 2 minus means 2 more hydrogens are added. So H12 becomes H14. So 12 plus 2 gives 14. B12 H14. 2 minus means added. So 2 electrons are added. 1 hydrogen gives 1 electron. So 2 hydrogens are added. So H14. 12 becomes 14. So 12 plus 2 gives 14. N plus 2. N plus 2 is Closo. Or we can say BnHn 2 minus is Closo. B12H12 2 minus. BnHn 2 minus is Closo in structure. And coming to this, cobalt eta by C5H by B4H8. So here this is a cobalt is a metal atom and C5H5 is a ligand, cyclopentane. So for representing these in B and hydrogen terms, boron and hydrogen terms, we have to find the electron deficiency of these atoms. So what is electron deficiency? So let's move on to that. So electron deficiency is what? How many electrons we need extra we need to attain 8 octet or 1836 like that. So electron deficiency for boron. First boron. Boron number of electrons is 3. Outer electron. So to attain 8 we need 5 more electrons. So to attain 8 we need 5 electrons. So electron deficiency is 5. So for boron, electron deficiency ED is 5. Now coming to BH, adding 1 hydrogen. So now the number of electrons became 3 plus 1, 4. So how many electrons we need to get 8? 4. So electron deficiency is 4. Now BH2, adding 1 hydrogen to BH. BH2, 3 plus 2, 5. Total 5 electrons. So to attain octet we need 3 more electrons. Now BH3, 3 plus 3, 6. To attain octet we need 2 more electrons. So this is the table of electron deficiency of B, boron, BH, BH2, BH3, boranes. So B4H8 is given, B4H8. Now we have to find the electron deficiency of cobalt eta by C5H5. For cobalt, how many electrons are there in outer shell? Cobalt atomic number is 27. 2 plus 7 is 9. So total 9 electrons are there for cobalt. 9. Plus, how many electrons for C5H5? 5 electrons. 5. So 9 plus 5. 9 plus 5 is 14. So total number of electrons that occupied by cobalt eta by C5H5 is 14. So how many electrons are needed to attain the octet? Not octet, not 8. So 14 electrons are there. So now the next number is 18. 8, 18, 36 like that. So to attain 18, how many electrons we need? 4. So electron deficiency of this complex will be, this structure will be 4. Electron deficiency is 4. So electron deficiency 4 is BH. So we will substitute CO eta by C5H5 with BH. So we can write this as BH. BH and this B4H8. So total number of B is B4 plus 1. B5. 8 plus 1. 9. So B5H9 is the final structure. Now we can find out the geometry of the borane B5H9. B5H9 is N is equal to 5. 5 plus 4 gives 9. So N plus 4 is nido. So this structure is nido structure. So what we have to do, find the electron deficiency of the substituent, the atom which we want to substitute with borane. So find the electron deficiency. How to find the electron deficiency? Count the valence electron. Count the valence electron of the metal atom and the ligand. Then add. Then find the electron deficiency, that is how many electrons we needed to attain 8, 18, 36 like that. So here cobalt have 9 electrons and C5H5 have 5 electrons. It is given here eta 5. It will donate 5 electrons. So 9 plus 5 14. So 4 more electrons needed to attain 18 number. So 4 is the electron deficiency. Electron deficiency is the how many electrons we needed to attain 8, 18, 36 numbers, etc. So electron deficiency is 4. So in this table, BH have electron deficiency 4. So we can replace this atom by BH. So we replace with BH. So BH, B4HA. Now adding boron atom and hydrogen atom, we get B5H9. 5 plus 4 is 9. So plus 4 means nido structure. Coming to this question, Mn, manganese eta 2 B3HA CO 4 times. So we want to replace Mn and CO 4 times. Manganese is 25. Atomic number is 25. 2 plus 5 7. So 7 electrons are there. And for CO gives 2. One CO gives 2 electrons. 2 into 4 8. 8. So 7 plus 8 15. So electron deficiency is what? How many electrons needed to attain 18? 3 more electrons. Electron deficiency is 3. So in table 3 is for BH2. So we replace this with BH2 and here B3H8. B3H8. So now we can add B3 plus 1 4. B4. 8 plus 2 10. B4 H10. B4 H10 is 4 plus 6, N plus 6. N plus 6 is arachno. Arachno. So the structure is arachno. So Mn 25, so 2 plus 5, 7 electrons in valence shell. 7 plus CO. 1 CO gives 2 electrons. 2 into 4, 8. 7 plus 8, 15 electrons are there in these two atoms. So electron deficiency will be 3. 3 more electrons are needed to attain 18 number. So 3 is the electron deficiency. 4 in the table, BH2 have electron deficiency 3. So these can be replaced. This can be replaced with BH2. So BH2, B3H8. Adding B4H10. 4 plus 6 give 10. 10 minus 4 is 6. 4 plus 6, N plus 6 is arachno structure. Now coming to 5th question. Pb5 2 minus. This is a Syntae ion. For Syntae ion, the formula is 4n plus 2, 4n plus 4, etc. So Pb, lead is in which family? Carbon, silicon, okay, carbon family. So lead is in carbon family. So how many electrons are in valence shell in lead? For carbon, the number of electrons in valence shell is 4. So for lead also 4 electrons will be there. So how many lead atom? 5 lead atom into 4 electrons. 5 into 4 plus 2. 2 minus is there. So 2 minus means adding 2 electrons. 5 into 4 plus 2 gives 22. So now we have to find the structure of lead Pb5 2 minus. How to find? We have to find any of the formula here. 4n plus 2, 4n plus 4, 4n plus 6, 4n plus 8. So 4n is 4 into n is number of atom. Here n is 5. 4 into 5 gives 20. So total number of electrons is 22. We got 4 and 20. So 4n plus any number. 4n plus 2 gives 20 plus 2 22. So 22 is getting by 4n plus 2. So plus 2 means closo. Now solving this Sn. So Sn is also in carbon family. Tin is in carbon family. So carbon 4 valence electrons. So 9 Sn. Tin is there. 9 into 4. 9 into 4 is 36. Plus 4. 40. So total 40 electrons are there in tin 9 4 minus. Now we have to find the structure. How to find the structure? Just do 4n. 4n is equal to number of n is equal to number of atoms. N is equal to 9. 4 into 9. 4 into 9 is equal to 36. Now we have to find the adding number. 4n plus any number. So 36 plus any number gives 40. 40 minus 36 is 4. So 36 plus 4 gives 40. So plus 4 means nido. 4n plus 4 gives nido. Now coming to this Ni5CO 11 times. This is transition metal, nickel. So for transition metal, the formula is 14n plus etc. 14n plus 2, 14n plus 6, 14n plus 4, 14n plus 8, etc. So nickel is the atomic number is 28. So total number of electrons donated by nickel is 10. So 10 into number of nickel atom 5. 10 into 5 plus 1 CO gives 2 electrons. 11 CO is there. So 2 into 11. Total number of electrons occupied by this complex is 50 plus 22 to 72. Total 72 electrons are there in this complex. So now we have to find the structure. So we will do 14n. 14n means n is a number of metal atom. N is 5. So 14 into 5. 5 4s are 20. 2 balance. 1 5s are 5. 70. So we got 14n as 70. So 72 minus 70 is 2. So 14n plus 2 gives 72. Plus 2 means closo. Now RH6CO16. Rhodium. Rhodium is in cobalt family. Cobalt, rhodium, iridium. So cobalt atomic number is 27. 2 plus 7, 9 electrons. So 9 electrons are donated by rhodium. So total number of electrons is 9 into 6. 6 is the number of rhodium metal atom plus 2 electrons by CO, 16 CO. So 2 into 16. So 9 into 6. 9 into 6, 54. 2 into 16, 32. So total how many electrons? 4 plus 2 is 6, 5 plus 3, 86 electrons are there in rhodium 6 CO16. Now we have to find the structure. So what will we do? 14n. 14n. Here n is 6 rhodium atom. So here rhodium number of rhodium atom n is equal to 6. 14n equal to 14 into 6. 6 4s are 24. 1 6 6 7 8 84. So we got 84. 14n is equal to 84. Now the total number of electrons is 86. So 86 minus 84 is 2. So 14n plus 2 gives 86. So this will be plus 2 will be closo. So using these formula we can find the structure of Syntae ions, transition metals, boranes and carboranes. And for carboranes, let's do one example. C2B4H8. So for carbon, we have to find the electron deficiency. So 2 carbons are there. So for one carbon, how many electrons are there? Total 4 electrons are there. So how many electrons we need to attain 8 octet? 4 more electrons. So electron deficiency will be 4. So in table, electron deficiency 4 is for BH. So we will replace carbon with BH. So BH, 2 carbons are there, BH twice. Then B4H8. Now we can add B, adding B4 plus 1, B5, and 8 plus 2, sorry, 4 plus 2, 6. 4 plus 2, 6, and 8 plus 2, 10. B6H10. B6H10 is 10 minus 6 is 4, plus 4. Plus 4 is for nido. So the structure is nido. Now we can see how to find the geometry of the complexes given by using the valence cluster electron. So how many, first we have to count the how many valence electrons are in the cluster. Then using this table we can find the geometry of the complex. So if the valence cluster electron is 18, then the structure geometry will be monomer. If 34, then dimer, 48 trimer, 60 tetrahedron, 62 butterfly. So this is important, 62 butterfly, 60 tetrahedron, and 64 square plane. 64 square plane. Trigonal bipyramidal is 72. If 72 electrons are there, cluster electrons are there, valency electrons are there, then this geometry will be TVE. Then square pyramidal 74, bicapped tetrahedral 84, and octahedral 86. For 86 electrons, the geometry is octahedral. And capped square pyramidal 88, and 90 trigonal prism, and capped octahedral 98. The marked geometries are very important. Monomer 18, dimer 34, trimer 48, tetrahedron 60, butterfly 62, and square plane 64, TVP 72, and 74 is for square pyramidal, and 84. So after 74 it comes 84. Bicapped tetrahedral, 86 for octahedral, capped square pyramidal 88, and 90 for trigonal prism, and 98 for capped octahedral. So let's solve two problems. Osmium 4 and CEO 14. So how to find the geometry? First count the total valence electron occupied by this complex. So osmium 4 osmium. So for osmium it comes under iron osmium. So for iron 26, 6 plus 2, 8 electrons. So valence electrons is 8. So osmium give 8 electrons. So 4 into 8. Plus Cu give 2 electron. So 14 into 2. 14 into 2. 8 fours are 32. 2 fours are 8. So total 10, 60. So total electrons occupied by osmium 4 CO14 is 60 electrons. So for 60 electrons the geometry will be tetrahedron. So just remember that table. So the geometry is tetrahedron. Now coming to this Fe5CO15 carbon. There is a carbon here. So iron will give 8 electrons. 8 into 5 iron atom. Then 1 CO give 2 electrons, 15 into 2, plus 1 carbon will give 4 electrons. So 8 5s are 40, 15 into 2, 30, plus 4. So 4, 3 plus 4, 7. For 74 electrons, the geometry is, for 74, geometry is square pyramidal. Square pyramidal.